Hey guys, welcome back. In this video we're going to drop down some test geometry. We're going to sort of proxy out a simple terrain that we're going to use as a testing system for our fence tool. Okay, so the terrain obviously will be an input in the game engine. We want our fence to conform to that. Okay, so let's get started. So I'm currently in our fence tool asset. I want to jump back up to object level. Okay, and I'm just going to temporarily turn off the display flag on my fence tool here. And I'm going to put down another geometry object. I'm going to call this terrain and jump inside that. Okay, so first thing, I'm going to put down a grid and I'm going to make it, say, I don't know, 15 meters by 15 meters. And I want to deform this surface, so obviously I'm going to need quite a lot more points. So we'll say, I don't know, 200 by 200. This is just for our testing in Houdini. Obviously, when it's used in Unreal, it might be a landscape or some other form of terrain. So we don't need to worry about polygon counts at this point. We just need to make sure our system is working correctly. And with that, I just want to sort of disturb the surface a little bit. So I'm going to use a mountain sop. I'm going to plug that in. And you can see the surface is all disturbed. I'm just going to raise the element size quite a bit. I'm going to increase the height a little bit. And maybe change the noise algorithm to something a bit more terrain-like, like Manhattan. Okay, so maybe just raise that element size a bit. Raise the height a bit. Yeah, something like that. And then what I like to do is just to make it a bit more terrain-like, I just want to clamp those values a little bit so we can chop off those tops and maybe chop off the bottom. So we're sort of clamping that noise a little bit to give us a bit more of a terrain-like look. All right, so we've got something like that, 2 nodes. Okay, now the goal is for our fence tool to follow the contours of this terrain or any other terrain. Okay, so if we wanted, we could go up to our offset here and we can offset this terrain and the fence will update for us. Okay, so let me just put that back to where we were. All right, so this is our terrain. And what I'm going to do here is just put an output node, which is like a flag that just says this is the last node of this network. Okay, so I'm going to put an output and call it terrain out. All right, so with that we can jump back to our fence tool and start making this system work with incoming terrain. All right, so this time I'm going to press U in the network view to take me back up to object level. I'm going to take the display flag off the terrain, put it back onto my fence tool and continue working. All right, so in order for this system to work, we need to bring in a reference to that terrain. Okay, because we need to do some calculations based on its surface. Okay, so we could do that with an object merge. So object merge, it does exactly what you'd imagine it does. It allows us to bring in objects from other parts of Houdini into other networks. And it also serves a really interesting function in Unreal Engine as well. So if your network has an object merge on your digital asset, that object merge field will be visible in Unreal Engine, so you can plug Unreal assets into it to work with your systems. And that's kind of the cornerstone of this system, being able to use existing geometry assets in Unreal Engine. So in the object we want to merge, we need to navigate to our terrain, and there you can see our terrain output flag there. So we're going to select that, and there you can see it's brought in our terrain. Now, one thing I forgot to do, which would really bug me, I want this terrain to be seated on the origin. So I'm just going to press U to jump up, go back into my terrain tool, and before my output, I'm just going to put an axis align and tell it to center everything. So I want it centered about the origin. Okay, and there we go. Jump back into my fence. That's better. So now that we've got our terrain coming in as a reference, we want to raycast our points onto it. Okay, so these points that we've got here, we want to project onto the terrain, okay, using ray casting. And you know, my mantra for this module is, you know, if you think you want to do something in Houdini, there is a node for it. So if we start typing ray, you can see there is a raycast node. Okay, so the raycast node takes two inputs, points or primitives, and then the collision primitive. Well, our collision primitive is our terrain geometry, and our points that we want to raycast are our points from our input curve. Okay, so if I plug that in there, okay, so what it's done, it's tried its best to map those points to the closest point it can find on the terrain. It's not done a very good job because it's the algorithm it's using is not quite right. So if we just drop down a transform node, and just for this raycast, if we just raise that up a little bit above the terrain, and then go to our ray SOP. Okay, we want to project these points directly down. Okay, so whatever it collides with, and we can do that based on a vector, and the ray direction we're interested in is down. Okay, so I can delete all these fields here by pressing Shift Control left click and then typing -1 into the direction field, and as you can see now, our points are now conforming to our terrain. Okay, cool. So with that, we can fix our broken network now. So we can plug our raycast into our attribute randomize. It will do all its stuff, and as you can see, our fence posts are starting to conform to the terrain. Okay, so I'll put the display flag on the merge. Now obviously there's a couple more things we need to fix. This plank here is broken, and our corner posts here are broken. So what we will do is we will take the output of the ray and we'll plug that into our attribute delete. Okay, and there we go, that's brought our fence posts back into it. And for our long plank section, what we need is our ray points. So we can plug our output from our ray into our sweep node, and that should update our, and it does, yeah. So you can see now our plank is now sweeping along that. And I'm just going to raise that up a little bit more. Something like that. Alright, so now we can see that our fence is conforming to the underlying terrain. If we want to see it all, we can press U, turn on our terrain. Shift W to turn off edge facing, and there you can see it's conforming quite nicely to our terrain system, and it's completely procedural. So if we jump into our terrain object, and here you'll notice we lose the visibility of our fence. We can fix that by coming up to this little option here, hide other objects, and if we click on that, we've got the option to show all other objects. Okay, so now if we select our mountain node in our terrain, and perhaps we can pin the parameters here so we can always see them. If we now play with the offset value, you can see how our fence is naturally conforming regardless of what terrain is underneath. And this behavior will be mimicked in Unreal Engine as well. So no matter what terrain you place it down on, it will automatically conform to the underlying terrain. And again, we can sort of start tweaking these values to really test it, to see. Obviously, it's going to break at some point, but it's where and when it's going to break that's important to us. So as you can see, it's quite a robust system, and we're sort of progressing towards the end now of this video. So what I'll say is, in the next video, is we're going to take a look at how we can add those vital attributes that are essential to us as game developers, in that all our geometry assets need UV coordinates, and we'll also take a look at how we can add some vertex color information in there for various effects. So I hope that was useful. Thank you for watching, and I'll see you next time.